Hi everyone, this is Unit 1, Lesson 3. EQ is how can we apply the properties of integer exponents to generate equivalent numerical expressions. Learning target is I can simplify a given exponential expression involving division by applying the quotient rule. It's going to be the same verbs as we had last learning target. We're going to simplify exponential expressions and we're also going to be applying. But today we're going to be learning about the quotient rule as opposed to the product rule. All right, for the brain starter, we see that it's the product rule because we see all of these x's having the same base and we see that they're all multiplying. So what we're going to do is we're going to keep the base as x and we're going to add all the exponents. And we know that if there's no exponent here, this is technically a 1. So we have 2 plus 4 is 6, 6 plus 3 is 9, plus 1 is x raised to the 10th power. And then to add on to that brain starter question, based on the previous lesson, predict what will happen when we apply the quotient rule. So if we were keeping the base and adding the exponents in the product rule, what do we think is going to happen in the quotient rule? And if you want to answer that question right now, please go ahead and answer that. If not, we're going to get to that in the mini lesson. For our example in the mini lesson, we have 4 raised to the 5th power over 4 raised to the 3rd power. So this is, we see that it's division. And if it's expanded out, we see that there's 1, 2, 3, 4, 5 4s on top and 1, 2, 3 4s on bottom. We know that if we cancel out a 4 on top, we can cancel out a 4 on bottom. Since there's only 3 4s on bottom, we're going to also cancel out 4 3s on top. So that means that we are left with 1, 2 4s. So that means it is going to be raised to the 2nd power. What pattern do you see when dividing two powers with the same base? So if we kept the base the same, 4 stayed the same, nothing changed about the number 4, and we started with 5 and 3, how do we end up with 2? That means that we're going to keep the base. And subtract the exponents this time. If we use the pattern to complete this equation, we have an 8 and a 3. 8 minus 3 equals 5. That means the 6 stays the same and the 5 is our new exponent. It's the same thing as the product rule, except we're just going to be subtracting the exponents. What is quotient rule of exponents? When dividing powers with the same base, we keep the base and subtract the exponents. We just discovered that. Make sure you put a period there. Let's come up with a couple of examples. If we have 8 raised to the 5th power over 8 raised to the 2nd power, what we're going to do is we're going to keep the base and subtract the exponents. 5 minus 2 equals 8 to the 3rd power. Another example with variables, let's say we have a raised to the 8th power over a raised to the 5th power equals a to the 8 minus 5, sorry, that's a subtraction sign, a to the 3rd power. Make sure we copy this down. You can pause the video at any point if you want to make sure that you have this copied down on your Cornell note. For work time, we are just going to copy down these 6 problems. So once these 6 problems are on your screen, make sure you pause the video and copy them all down. Numbers 5 and number 6 are extension problems. And then the closing is your usual closing question. Closing/summary, what has resonated with you in today's lesson? What questions do you still have? And then I guess another thing that you can include in your closing/summary, if you feel as though you're stuck, you can relate it back to the product rule. So how does the quotient rule differ from the product rule? That's a great question for you to answer if you would like to include that in your closing/summary. If you have any questions, feel free to reach